corn and how to, so this farmer has a field and he breaks it up into 16 even plots, and he wants to get a sample of the field. He wants to take 4 different plots and based on that sample, figure out like the average yield of his field. So I had to do this at home. So I am using the notes that I did from last year. So I won't be able to write on this, but I'll just talk you through what we did last year. So hopefully it makes sense. Okay, so the one way that the farmer could take a sample of his field is he could, again, label his different plots 1 through 16 and do any method to find a simple random sample. So for example, if you use your calculator and you do random int, so there's plots from 1 to 16, and we're going to want to pick 4 of them. Okay, so again, on your calculator, if I can get my calculator to come up. So you're going to hit math and then go over to probability, and then number 5 here is your random int. And so the lowest value is 1. We have 16 plots, and we want to pick 4 of them. Okay, so when I did that this time, this is the values that I got. But again, last year when I did it, the values that I got were 11, 4, 8, and 2. So there's those plots right there. Okay, so that's one way he could take 4 of his plots to figure out the average yield of this cornfield without actually, finding every single one. Another way that he could do that is he could take a stratified random sample, and we'll talk a little bit more about that after this, but basically you break up your data, or in this case your fields, into some kind of similar categories. So in this case, each row is its own, or sorry, each column is its own strata, is its own category. And then when you do that, you end up getting, so each column is the strata. So when you do that, you actually end up getting one value from each row. Okay, so again, when you would do this, you would basically say, okay, so this is column 1, this is column 2, 3, and 4. So then for each row, you're going to say, okay, I've got values of 1 through 4, and I want to pick one of them. So you go to your calculator. I'm going to do random int. And then I'm going to say, okay, I've got from 1 to 4 in that row, and I want to just pick one of them. And I'm going to get number 1, okay? Although again, last year when I did that, I got number 2. And then you'll do that 1, 2, 3, 4 separate times so that you get a separate choice from each row, okay? So you could stratify so that you get something from each row, or you could stratify the other way so that now I'm saying, okay, all of row 1 is 1, all of row 2 is 2. And then when I do that, I'm going to do the exact same thing on my calculator. And so when I do random integer 1 through 4, pick one of them, I'm going to get one value from this column. I'm going to get one value from the second column, one from the third, and one from the fourth. Okay, so I'm stratifying by row, and then that gets me one value from each column. So when you do this, you obviously get different values each time you do it. So you want to think about what would be the best way to choose a random sample. All of those are random samples. All of these are random samples, but in different situations, one method might be better than another, okay? Something that probably is not a really great method would be a convenience sampling. So if you think about if the setup is like this, okay, if this is the farmer's 16 plots and here's the river, and his house is over here, like he could just take the 4 plots that are the closest to his house. But again, that's, you know, convenience sampling often leads to bias. And in this case, if you think about it, you know, what would you think about the yields of your plots that are near the river versus plots that are further away from the river? Like probably the ones near the river are going to yield more corn than the ones over here. So if he does this, there's going to be a problem, and it's probably going to underestimate the actual value, the actual yield of corn in this field. So convenience sampling would not be a good way to do this. So hopefully at this point, you've got, for your 3 different random samples that you took, you've got your different 4 plots. So what you're going to do now is, well, we'll come back to this for in a minute once we've like looked at it. So now what we're going to do is we're actually going to, okay, so the farmer actually has, you know, the 16 yields, the values for the 16 different plots. And if you found the actual mean of those, it would be 70. Okay, so what you're going to do now is you're going to pause the video for a second, and for each of those 4 plots that you have, you're going to find the mean yield of those 4 plots. So for example, my first simple random sample that I did just by picking any 4 of the plots with the calculator, I got 11, 4, 8, and 2. So here's 11, the yield there was 92. 4, the yield was 150. 8, the yield was 153. And 2, the yield was 29. I had 4 plots, so I got an average yield of 106, which is quite a bit higher than the actual mean. Okay, so for your 3 different simple random samples that you, or the random samples that you took, figure out the mean of each of them, and then on the next page you will plot them on your dot plot. Okay, so you can pause this and go look at that and work with a partner and do that. Okay, and so now if you're back, so with my simple random sample, my mean was 106. When I stratified by row, so this was when my columns were like the groups, and so I got 1 from each row. My mean was 106.75. I don't know why that dot is so big. And then when I got 1 from each column, my mean ended up being 70. Okay, so yours might not be exactly 70, the actual mean, but hopefully it's pretty close to that. Okay. So seeing this, you know, hopefully you guys can talk to one another and see if you got a similar result. See if when you did either the simple random sample or the stratified by row, maybe you got, you know, something pretty far away from the mean, either too low or too high. And then if overall as a group, you got values much closer to the actual average yield of this farm. And why would we expect that to happen? So if we go back to this question, you know, which one do you think would work the best? So if we have the stratified random sample where we get 1 from each column, okay, so let's go back to that one. This was the one that gave us the best value, right? They're the best, closest value to the average yield. So basically, ideally what we want is we want to get, you know, some values that are close to the river and some values that are further away from the river. So when we get 1 value from each column, then we're ensuring that that's going to happen. So there's going to be different soil type closer to the river versus the soil type that is furthest away from the river. So this stratified random sample is ensuring that we're getting samples far away from the river, close to the river, and everything in between. Okay. So So it's really important when you're doing a stratified random sample that you think about what you want your strata to be. So a little more information about stratified random samples. So up here at the top, it's saying when we pick our strata, we want to pick strata that are similar within but different between. So what that means is similar within means like all of our columns or all of our rows or whatever are similar within one another. So when we did, when we picked a row, you know, all the rows are similar to one another, but they're different between one another. And we'll do more examples of this. Another way to think of a stratified random sample is you're taking some from all. So the one that gave us the best or the closest approximation to the mean, we got some from all the different types of soil. So we got some that were close to the river and some that were far away from the river. And a stratified random sample is basically just you're taking an SRS, because we did our random integer. You're taking an SRS from strata of similar individuals in the population. And so when you're doing that, you first want to group people or individuals or your data on a common characteristic to get a representation of all of strata. It's beneficial to use a stratified random sample so that you're not randomly selecting a whole bunch of individuals that are very similar to one another. So it ensures that different types of individuals are getting chosen when you're doing your sample so that it's more representative of the entire population. And when you choose a variable to stratify by, you want to use a variable that has the strongest association with whatever it is that you're trying to learn about. So for example, if you wanted to take a survey about Social Security, and you're going to ask people, you know, how they feel about whether or not the government should continue providing Social Security benefits. Well, the people that are going to be the most invested in that and the most have the strongest opinions about that, or it's going to affect them the most, would be based on either their age, because the older you are, the closer you are to getting Social Security and needing that, or maybe income would also be a good one, because poorer people would be more dependent on their Social Security benefits as opposed to wealthier people who could plan for their retirement without having to worry about Social Security. So those would be two different categories that you could stratify by. Like gender would probably not necessarily be a great one to stratify by, because men and women in general, there probably wouldn't be too much of a difference about their opinions about Social Security. So that's how you kind of figure out what you're going to stratify by. Okay, so the last thing that we're going to do is we're going to do 4.1c. And if you don't finish this in class on Friday, it would be great if you finished this for homework. If it turns out you guys don't get through a ton of it, then when I get back on Tuesday, we'll just figure it out. But the more that we get done, the better. So maybe at the end of class, you guys can have a game plan of like, how far did you get? How much do you think is reasonable to do for homework? And then maybe somebody can send me an email. That'd be awesome. Okay, so the last little bit in this section, so a few more ways that you can sample. So another way to sample is to get a cluster sample. So in a cluster sample, you take all from some group, okay? So for example, you group a population into clusters based on location, and then you're going to choose a simple random sample of the clusters, and then you're going to sample all of the individuals in the chosen clusters. So